This tutorial video is following Forte Tutorials Chapter 2, Simulating Diesel Engine using a sector mesh. First, select the Forte from toolbar and drag and drop to the project schematic. Then double-click this setup to launch the Ansys Forte. Okay. First, to make the geometry, right-click this geometry and select the Launch Sector Mesh Generator. Okay, then select this engine parameters and choose create new from drop list of ball profile and click this pencil mark. And this window shows the cylinder head ball profiles. On this time, we're using the prepared parameters. So select this load CSV and choose Sandia ball profile CSV to open. Then this window showed, please uncheck this read column titles and click OK. Okay, then the profile changes. This ball profile is determined by 3 points. Very simple ball profile. And change the name to the Sandia ball. And click save and close. Okay, then change the ball profile to the Sandia ball and change the engine parameters. Sector angle 45 and bore is 13.97 and stroke is 15.24 and squish is 0.56 and crevice wise 0.167 and crevice height 3.72621. Okay, then click apply. Okay, then the area was generated. Then choose this mesh parameters. This time select the topology as a 3 and enter the circumferential cell count as a 21. Radial cell count 1 is 16. I2 is 11. I3 is 3. And K1 is 11. And K4 is 21. And K5 is 11. And smoothing passes as a default 20. Okay, then click the apply. Next, click this generating a mesh. Okay, then the mesh is generated. Okay, next is click this import to Forte project. Then close this sector mesh generator. Okay, then back to the Ansys Forte and click this button to show the mesh area. Okay, next import the chemistry reaction and click this models. Choose this chemistry and click this button. And this Ansys prepared a default reaction for famous some reactions. And this time choose this D01 component 35 species CKS and click open. Okay. Then next to the fuel inject spray model. Check this the top of transport spray model and select new solid cone injector. Set the name as injector 1. Then the time frame is default global time, and composition, select create new and click this pencil mark. And click this add spaces button. And this time choose NC7H16. Okay. Spaces is this, but change the physical property as n tetradecam. Okay, the mass fraction is 1. Then please press enter button. Then the fuel mixture was shown. Okay, then click save and close. Okay, injection type is default and changing from default injection type is default post injection, and change the parcel specification from droplet to number of parcels, and set the parcel count as 4,000. and set inflow droplet temperature as 368 Kelvin and mean cone angle as 15 degrees. Then other parameters as a default, and click this apply. Next, click this new nozzle. And the sets the location. The core system as a cylindrical, and radius is 0.15 centimeters. Theta is 22.5 degrees, and A equals 19.368 centimeters. And set the spray direction. Core system as a cylindrical, and radius, the spherical, and theta is 104 degrees, and phi equals 22.5 degrees. And nozzle diameter has a 1 centimeter, and click apply. And the spray will show on these models. And next to says the injection. Click this injector 1 again, and click this new injection. Okay. Then set injection type as a default post, and select crank angle. The start of injection, and duration set as minus 22.5 to the 7.75 degrees. And the total injected mass set as 0.0535 grams, and click apply. And next, change the velocity profile to the create new, and click this pencil mark. change this column 1 unit as a none, and load CSV, click this load CSV. And load the prepared file injection profile CSV. Okay, this time please don't uncheck this read column titles. And press OK. Then the profile will show. Then go to the name, change the name, and click save and close. Okay, then change the velocity profile to the injection one. Then click apply. Okay, next to the boundary conditions. Please click the piston and set and scroll down and set the piston temperature 500 kelvins. And turn on the roll motion, and motion type is slider crank. The stroke is 15.24 centimeters, and the connecting rod length is 13.48 centimeters. And don't check this piston is offset. And check the reference frame as a global origin, and direction parameters So, and next click apply. Okay, then the top of the cylinder head will show. And next click the periodicity. Set the sector angle as a default 45 degrees. And selected boundary condition is periodic A and periodic B. Next, click this head. And head temperature set as 470 kelvins. Click apply. And the liner is set to 420 kelvins. Click apply. And next, set the initial conditions. Select the composition as a constant and change this composition to the create new and click the pencil mark. Change the composition to the mole fraction and click add spaces. This time select the O2 and N2 to add. O2, okay, and add spaces. N2. Set the O2 fraction as 0.126. Then press enter. Now N2 is 0.874. Enter. And the gas mixture of the injection will show. And change the name. Okay, then click save and close. Set the temperature as 342 Kelvin and pressure as 2.215 bars. Okay, be careful about this. Not the default atom. They change to the bar. Then next, determine the velocity. So change the top of this one is default constant, and the next one change to the engine swirl, and set the initial swirl ratio as 0.5, and the initial swirl profile factor is default 3.11. And click apply. Okay. And next to the is determine the simulation limits, and click this simulation controls. This time is default crank angle based, and initial crank angle is minus 165 degrees, and final simulation crank angle is 125 degrees. RMP is 1200. Cylinder type is default 4-stroke, and click apply. Next, click time stop under the simulation controls. Check this advanced time step control options. Rate of string factor as 1.2, and convection factor to the 0.5, and other parameter is default setting. Click apply. And next is change the chemistry solver. Turn on this use dynamic adaptive chemistry. Oh, sorry. It's default use dynamic cell clustering. And go to the bottom of this list, change the activate chemistry to the conditionally, and specify when temperature is reached, change the threshold temperature to the 6000, and click apply. And next, to set the output controls. Choose this spatially resolved output controls. and specify the crank angle output control and output every 5 degrees. And check the user-defined crank angle outputs and turn this blank as a create new and click pencil. Then use the prepared CSV files user crank angle outputs CSV, and this is a very simple file to the -22 to the +20. Please uncheck this read column titles and click OK. The file loaded, and change the name. Then click the save and close. Okay, then go to the bottom of this list. Then select N2, O2, CO2, H2O, CO, NO, and NO2, and NC7H16, and click apply. Then go to the spatially arranged and spray, and go to the bottom of this list and choose all spaces to a selection. Okay, then select the spatial average output control and set the crank angle as a default 1 degrees. Okay, then click apply. And next, go to the restart date. Please check the right restart file at last simulation step. Okay, if you changed, please click apply. Okay, then go to the simulation step. Please click the run simulation. Then if you click this green arrow button, you can start the simulation. Oh, sorry, I forgot to set the piston boundary. Piston boundary is must set this piston to the selected. Then click apply. Okay, sorry. Okay, then click the start. Okay. Then the simulation will start. and click this monitor runs. You can open the simulation result files. And now the simulating status is running. So the file is not complete, and if the simulating complete, you can view the result files from this. Okay, this simulating will take about 2 hours in my desk computer. So I'll stop that. I'll finish this introduction. The result, please check by yourself. Okay, thank you. Goodbye.